All right, today we're going to start talking about the next section, which is 10.2, chapter 10.2, which is all about angles and arcs. Before I get into new stuff with circles, I just want to remind you that we have the different types of angles: acute, right, obtuse, and straight angles, each that are either less than or equal to 90 degrees. And that's all going to come into play today. And we're going to see how angles can be related to arcs. And when we talk about arcs, what is an arc? An arc is actually just portions of a circle. So if I were to draw a circle here, oh, that's not bad. And let's say I wanted to just talk about a portion of that circle. So let's say I went from here to here and I wanted to erase the rest of the circle, right? So I took my eraser and I erased the rest of the circle. That part that remains, this curve here, this is what we call an arc. So we're going to be talking about how arcs are related to angles. Another thing that I want to point out to you guys is, since we've got angles that are 90 degrees, less than 90 degrees, greater than, we even have straight angles that are 180 degrees. How many degrees do you think would be a angle that started here and came all the way around and ended in the same spot, that went full circle? How many degrees would a full circle contain? 360 degrees, right? So a full circle would be 360 degrees. So keep that in mind as we're going to be talking about some vocabulary here. All right, this lesson should be much quicker than the last one. I have just a couple of vocabulary words to describe to you, and we're going to go over an example, and that's it. So the first vocabulary word that I want to go over with you is something called a central angle. Let me zoom in on this. What is a central angle? A central angle is an angle with its vertex at the center of the circle. It separates the circle into two arcs. Okay, so the vertex is at the center of the circle, hence the name central angle. There's lots of central angles in this diagram. I'm only going to pick one of them. In this case, I'm going to pick this one here. I'm going to highlight it for you in green using my pen. This is an example of a central angle. Notice how if I take this angle, and if I could take scissors and I could cut this circle, you're going to see two arcs. The first arc that you're going to notice is this arc here. The other arc you're going to see is the arc that goes all the way around to the other side. If I could, this large arc all the way around the other side. Okay? Together, these two arcs form a full circle, a full 360 degrees. But individually, you have two separate arcs. Anyways, going back to naming my central angle, since it's an angle, I'm going to be using the angle symbol, like this. You could also put in that extra mark there. And remember, we use 3 letters to name an angle. In this case, this is called angle ACE. Remember, my middle letter is always the vertex. So in this case, the vertex is C, and it's on the center of the circle. You could name this the same angle, ECA, or, well, I guess I couldn't call it angle C because there's too many angles that could mean. So either ACE or ECA, central angle. All right, let me go back to those 2 arcs that I had mentioned. There's a couple, actually, you know what? Let's go through some of these vocabulary words. The next vocabulary word you're going to see is a semicircle. What is a semicircle? It's actually, you guys have seen this word, it's another word for a half circle. If a full circle is 360 degrees, then a half circle would be 180 degrees. And that's what a semicircle is. A semicircle is an arc with a measure that is exactly 180 degrees. So that's important. Okay? Exactly 180 degrees. So in this case, we name it with this symbol here, a semicircle, an arc. An arc, we use a symbol that looks like an arc. It's just a curve. And we're going to use letters to represent that. In this case, one semicircle would be this here. See how we have E, this from E all the way down to D? This is an example of a semicircle. Actually, if I go the other direction, that's another semicircle, because it's just the other half of it, the left half of it. But how do I name the semicircle? I need 3 letters. So I need 3 letters. I'll go back to this one. So since I'm starting on E and I'm working my way down to D, I'm going to call this semicircle EAD. And that's what I'm going to write here. EAD with this new arc symbol, like that. It's kind of like a line segment symbol, but it's curved instead. EAD. Or I suppose I can go in the other direction. What if I started down here on D and went up? I could call this DAE, arc DAE. I have another semicircle. I could go around this direction, I suppose, right? The original direction I told you. In this case, since I'm starting with E and ending with D, I need to pick one of these points to go in the middle. And it doesn't matter which one. It could be B or F. So for example, I can call this arc here, this half circle, semicircle, EBD. Or I could have called it EFD. And I can reverse those letters. I could say DFE as well. But I can only use 3 letters. So I should not be calling this something like BFD, arc, right? You cannot do that. You only need 3. Now, why 3 letters? Why bother at all? Because what if I told you I want you to highlight arc ED? Well, I see the endpoint E and I see the endpoint D, but which arc are we talking about? Do you want me to go towards the left? Or do you want me to go towards the right, Miss Lee? I don't know. Which is why you need that 3rd letter to tell you which direction. So if I wanted you to highlight arc EAD, where's EAD? I see, here it is. We're going towards the left half of the circle. So that's why you need 3 letters to help you name these semicircles. So you shouldn't use 4 letters. You shouldn't use 2. You should use 3 letters. So make a note of that. All right, there's other types of arcs. There's something called a minor arc and a major arc. A minor arc is an arc with a measure less than 180 degrees. In other words, a minor arc is smaller than a semicircle. Kind of like acute angles, right? So it's less than 180 degrees. In this case, a minor arc can actually only use 2 letters. You don't need 3 letters. You actually could just do with 2. Let's take a look at an example. So going up to this picture, I'm going to use this central angle that we had earlier. Arc AE here is an example of a minor arc. I know for 2 reasons that it's a minor arc. The first reason is because it tells me right here that it's 45 degrees. So that's less than 180. Another reason why I know it's a minor arc, because when I look at the diagram, it's clearly smaller than a half circle, than my semicircle. So there. I don't need 3 letters because it's so small. AE, that's the arc we're talking about. So there's an example of a minor arc. I'm going to say arc AE. And there's plenty of other arcs here. Minor arcs, I could say minor arc DF is another example. I could say minor arc AD. Here's another example of a minor arc. It's less than 180 degrees. I can tell because it's less than a half circle. Actually, BF, here's another minor arc. I could say, I can say EF. Okay. I don't need 3 letters. I could call this EBF, but EF is good enough. So there you go. That's a minor arc. A major arc would be an arc that has a measure that is more than 180 degrees. And that's what makes it a major arc. In this case, major arcs, you do need 3 letters to name. And it's for the same reason that you need 3 letters for semicircles, so you don't know which direction to head. Here's an example. Major arc, something greater than 180. Okay, so I guess, let's see. Let's start on E, and greater than 180 would take me all the way around to like something like this. This is one example, right? So if I had called this arc EF, you would have just went off in the shortest distance and said there, in blue. This is arc EF. No, I want you to go the other direction. So in this case, this is why I need that third letter, a middle letter, so that way you know which direction to head off into. In this case, since I started with E and ended with F, I'm going to pick one of these points in between, A or D. It doesn't matter. Let's go EAF. So one of my major arcs in this case is arc EAF. Notice how I'm using the arc symbol, 3 letters. My 2 end points are the end points of my name, and the middle letter is just one random letter that happens to be in between them. So when I look at this example, A is in between D, E, and F. I could have chose D, doesn't really matter. Another example of a major arc, let's see, it could be anything. It could be, let's see, what if I start on B and I go all the way around to D? I could do that. And I know that's a major arc because it's greater than a half circle. So let's see, since I start with B and end on D, let's pick a letter. E. E happens to be in between. So another example would be arc B, E, D. Let me write that down. Another example is arc BED, bed. Haha. All right, so again, my endpoints of the arc, and then I pick a random letter that happens to be in between. All right, so there we go. These are major arcs, minor arcs, and semicircles. Now, how are these all related to each other? There's actually one very important thing that you need to know, a property about central angles and arcs, and that is this. A central angle has the exact same measure. They are equal in measure as their associated arcs. They have the same measurement. In other words, the same measurement degrees. And so we measure arcs and angles in degrees. So they have the same measurement. They're not congruent because remember the word congruent means equal in size and shape. Arcs and angles are not the same shape, but they do have the same measurement in degrees. So that's kind of neat to know. In other words, let's take a look at this example. Earlier, we had mentioned that AE is 45 degrees. This arc is 45 degrees. Well, if that arc, AE, is 45 degrees, that means this central angle here, ACE, is also 45 degrees. In fact, I can say that since this arc over here is 60 degrees, that means this angle is also 60 degrees. By the way, these are not vertical angles because, as you can see, this line here is really crooked, so it's not a vertical angle. So anyways, if you knew the angle measure, then you know the arc measure and vice versa because they're going to be the same. And at the end of the day, if I were to go full circle and if I could add up all of these angles, you should get a total of 360. Actually, let's do that. Let's continue finding the rest of these angles and arcs. So for example here, actually, let me see if I can put this on my screen. Okay, I'm going to take a look at some of these examples. Let's just do these ones here. First question. I see here, I'm trying to find the measure of angle, see the symbol angle, FCD. So FCD, let me highlight this, FCD, angle FCD. I already did that, that's 60 degrees, perfect. and that's a central angle. Okay, let's take a look at the next example. I want to find the measure of arc AE. Take a look at the symbols that they're using. The measure of arc AE. Oh, we already found that as well. That's 45 degrees. It was actually given to us. So that's 45 degrees. Okay, next question here is arc ADF. Look at how they're using 3 letters here, ADF, arc. So here's A. I know I'm starting with A and I'm going to end with F, but which direction should I head? Should I go up towards the top or go down towards the bottom? And that's why you need that middle letter, D. ADF. Here's D, so that means I'm going this direction. This is arc ADF. How many degrees is this guy? Well, I only know a part of it. I only know this part, DF, is 60. What is this other portion over here? How could I figure that out? Oh, wait. I do remember that we had a semicircle. Since ED here is a straight line, doesn't that mean it cuts this in half? This entire portion, this arc here, is 180 degrees. If that's 180, and we already know this portion is 45, then can I just subtract the 2? And that way I can calculate what the other arc is. And there we go, 135 degrees. That must mean this arc, AD, is 135 degrees. Which makes this inside angle, this central angle, also 135 degrees. You know what? I can do the same on the other side of my circle as well. Right? We have a semicircle. This is a half circle. This is 180. If I do 180 minus 60, I get 120. So this over here is going to be 120 degrees from E down to F. So I can also label this central angle as 120. There we go. I have enough information to go back to my original question. What is the measure of arc ADF? Oh, 135 plus 60, that's 195. And there we go. 195 degrees. Let's keep going. What is the measure of arc AD? So arc AD, we calculated that. Arc AD is 135 degrees. There we go, 135. Angle ACD, angle ACD. Now remember, since the arc is 135 degrees, its central angle is the same, so that's also 135 degrees. Its angles and arcs, corresponding arcs, are the same.